we have a parent nucleus decay into two daughters, M1 and M2. They move away from each other in opposite direction, and energy E is given out, okay, during this decay process. So what is the energy associated with the daughter 1, okay? So basically, right, this process is like this. You have the parent turning into D1 plus D2, okay? And energy is given out. So this energy, right, is simply the KE of the daughters, the gain in KE of the daughters. Let me just write it out. Yeah, why is there a KE manifesting? It's because, right hand side there must be less mass, left hand side must be more mass, okay? I'm just helping you see the what's going on here. Now let's move on. So when we look at the particles, right, see, this is the initial parent, so this P, this before. Then after, right, turns into like this. It turns into two guy. So this is M1 and this is M2. Yeah, and before, right, the momentum is 0. P initial is 0. So this means, right, that the final momentum, total momentum must be 0 as well. That means, right, M1 and M2 must carry equal momentum in opposite direction, such that, right, the total final momentum is also 0. Okay? Yeah, and now let's relate, right, the KE to the momentum. So we know KE is half mv square, right? But in nuclear physics context and also in quantum context, right, we seldom use half mv square. We always use p squared upon 2m. Okay, so this is the equation. We turn the equation into a proportion step. So you see that the KE is actually, right, proportional to 1 over m. Why? Because, right, both particles have the same momentum. So momentum is a same quantity for both, or it's like a constant. So KE only depends on the mass. Yeah. Therefore, right, KE of 1 is to KE of 2, right, or will be equals to m of 2 is to m of 1. Okay, so we are saying, right, that if total we have this amount of energy, let me draw a line or a box here. Then, right, this total energy we call it E. Okay, this guy, the mass 1, will have m2 parts of the total energy. So m2 parts. So it's just like in primary school, right, P6 you do all those kind of problems, and whereas, right, this one is m1 parts. So you must ask, right, so if one of them carry a m2 parts of the KE, m2 is just referring to a number. You can think of it as, right, for example, we can say that this m1 is equals to let's say 5 and m2 is equals to 8, for example. Okay, yeah, then altogether how many parts there will be? There will be 13 parts. Yeah, so together, right, why do I write 13? So m1 plus m2 parts, right, will represent E. Okay, therefore m2 parts represent what? m2 parts, right, will hence be equals to m2 over m1 plus m2, which is the total, times of the energy E. Okay, so this part, right, I think if you see for the first time, you'll be not so oriented. Okay, it's fine, because it's given in a very generic way, m2 plus m1. You look at the next question, right, I think you'll have a better sense of things.